Hey everybody, my name is Greg, and today we're going to be discussing LTSPICE, which is the circuit simulator that we use in our class. So to begin, go to the Start menu and click on the LTSPICE icon, and you can see a new project will be opening up. If you click over to here for a new schematic, you can set up your workspace in that way. There's a lot of cool things that you can do with LTSPICE. For example, if you want to add components like resistors, capacitors, inductors, diodes, a lot of different choices you have up here. But if you want to add some more advanced components, you go over to this icon here, which is just called component, and you can select from a number of different libraries that are available, and they include NPN transistors, as well as PNP transistors, more advanced diodes like the Zener diode structure or the Schottky diode, variable resistors, voltage sources, both voltage and current sources, LEDs, a lot of different types of things that you can get in this menu. So let's set up a circuit, and we'll start off with a voltage source, which I'll grab here. Called voltage 1. Now, I only want one voltage source, so I'm going to right click and get rid of the component selector icon. I'm going to grab a couple of resistors too. So here I have one resistor, and if I hit Control R, I can rotate that resistor around to the orientation that I would like. I'm going to place one here, and place one here. And then I'm going to hit Escape, or again right click, you can hit again. And I'm going to add a ground. LTSPICE will not run without a ground, so you have to have a ground at some point in your schematic. Now to wire all of this together, you go to this symbol right here which says wire, and click on it. You can now add all of the traces that go from component to component. You just click once, drag it over, move it around, click it again, and it will be where you want it to end. So I'm going to just place these around like so, and connect everything up. Now, we have a circuit here, and we have no values for these resistors or for this voltage source. So what you do to assign those values is you right click on the component, in this case R1, and you get a screen that shows what kind of resistance, tolerance, and then power rating you want to have. So let's make this a 100 ohm resistor. So I'm just going to place 100 ohms in here and hit OK. And you can see that the value here has changed. R1 is now 100 ohms. I'm also going to place this, I'm going to make this one 100 ohms too. We have two 100 ohm resistors in series, and I'm going to change this voltage source to 10 volts. And I'm also going to show here real quick all the different types of voltage source that you can implement with this one circuit symbol. So if you wanted to do a step response, you could use a pulse here, and then have initial voltage of 0 and an on voltage of 1. You can have your delay. Let's say you wanted to wait a half a second, so then it would be 0 and then pop up to 1. You can specify the rise time and the fall time. And then if you want to do a periodic symbol, you can do the time for the period and the number of cycles. You can also do sinusoidal voltage sources here. So if you want to have an offset in the sinusoidal wave, you would specify it here. You can give the sinusoid an amplitude, its frequency, again, phase, delay, number of cycles, all of that. And if you're doing small signal analysis, you would fill out this little block over here. We're not going to be doing that today, but it will come in handy later when we're examining bipolar junction transistors. So let's just stick with our DC voltage source. Again, 10 volts, what we said earlier. So just hit OK. And now you can see that this voltage source has been changed to 10 volts. So in order to simulate this schematic or circuit, you go up here to Simulate, and you would need to set up some type of simulation command. So there's a lot of different types. You can do a transient analysis. You can do an AC analysis where you sweep across a range of frequencies. You can sweep across a range of DC values. You can do noise analysis. calculate the DC transfer function and the DC operating point. So let's do this operating point for now and hit OK. And this shows up here. This little item here describes what type of simulation you're doing. So this is the operating point. Now we can just hit simulate over here, and we get a listing of the voltage and currents in each device. Now I'm going to put this over to the side and show you how to interactively query the circuit. And let's move this over to here. And you can see that, actually I'm going to X out of this. You can see that if you hover over this resistor, you see a DC operating point in this section right here. So in this case, our DC operating point is 50 milliamps flowing through this resistor and dissipating 250 milliwatts of power through here. So you can also go to this node over here and get the voltage at this node. So in this case, it's 5 volts, and that makes sense because it's a voltage divider across 2 equal resistances. So it's going to be half of our starting voltage here. So 5 volts here. Again, current dissipated 50 milliamps, which makes sense because current in this resistor should equal current in this resistor. 50 milliamps in here, 50 milliamps in here. And then it's the same resistance value with the same power dissipation, so 250 milliwatts in both resistors. And now we're back to ground. So that's a quick overview of LTSPICE. And if you wanted to save it, you would save your schematic over here, give it a name and a place on your computer. And that's about it. So thanks a lot, and we'll talk